At what time will the object be at point S? Now there are two ways that you can do that. You either go to this equation, number 3, and you ask equation number 3, when are you 0? It will give you two answers. It will say, I'm 0 here at this time, and I'm 0 at that time, and those are the two times that you want, and this is the one you pick. That's perfectly fine. I think there's a faster way to do it, and that's the following. This is a parabola, so it's completely symmetric about the vertical about P. So to climb up from O to P must take the same amount of time as to go down from P to S, and so I claim that the time to reach point S must be twice the time to reach point P, and therefore it's going to be 2v0 sine alpha divided by g. But now we want to look again whether the v0s and the sine alphas have the right place. Indeed, if I increased the speed, I would expect it to take longer before it reaches S. If I give it a larger speed, it will come out farther, and obviously the time will take longer. If I do it at a higher angle, it will also take longer. And if I do it on the moon, it will also take longer. So this makes sense. These equations are pleasing in terms of the way that v0 and sine alpha appear in the equations. But now comes an important point which I'm going to use throughout this lecture. I want to know what OS is. The distance OS. I shoot it up and it hits the floor again. What is that distance that it travels? Well, for that, I need equation number 1. It is v0x times the time. And v0x is v0 cosine alpha. So we get v0 cosine alpha times the time to hit it. That is 2v0 sine alpha. So I get a 2 here. I get a sine alpha. And I get a g here. And I have another v0 there. And so the answer is v0 squared times the sine of the double angle. Remember, 2 cosine alpha sine alpha is the sine of 2 alpha divided by g. And this is OS. And I'm going to need this a lot. This reminds me not to remove it. Now, I sort of wonder, and you should too, why is it that the highest point in the sky has a v0 squared, and why is the farthest point also, why does it also have a v0 squared? There must be a way that you can reason that. Why is it not just v0? Why is it v0 squared? Well, I'd let you argue about the highest points, and I'll give you a good reason for the distance, OS. Don't look at the equations. Just simply think for a change. Don't look at the equations. I double the speed. If I double the speed, then it's quite reasonable that the time that it takes for the object to reach the ground will double. But while the time that it flies has doubled, the horizontal velocity has also doubled. And so the distance that it will travel in horizontal direction is 4 times that. Twice because the time has doubled, and another factor of 2 because the horizontal component has also doubled. So that's why you see a v0 square there. It's completely pleasing. This tells you immediately that if you want to throw a ball as far as possible, people who play baseball know that, you should do it at 45 degrees. Because if you throw it at 45 degrees, then this angle 90 degrees, and that is 1. Now, of course, in reality, a baseball player knows better. They give effect to the ball, they deal with air drag, they spin the ball, and then these equations are not valid. This is only in case we deal with vacuum. I now would like to test some of the results that we have here, that we have worked out here. I'm going to shoot a pellet, a metal ball. I'm going to shoot it at various angles. 30 degrees, 60 degrees, 45 degrees. And I'm going to make a prediction, if I shoot it up from there, where it will hit the table. A measurement is meaningless without knowing the uncertainties. So that's the first thing we have to deal with. The first thing I want to know is what is the velocity of this bullet when it comes out of the spring? And does it vary if I do it 3, 5, 6 times in a row? It's not a $20,000 spring gun, so it is likely to vary. And the way I'm going to do that is as follows. If I shoot an object vertically up, that is the maximum value that it can go. So when alpha equals 90 degrees, then the sine of alpha is 1, then the height is v0 squared divided by 2g. In other words, if I measure the height, if I shoot it up vertically, and you can measure that for me, you will see how I'm asking you to do that, then we can calculate v0 squared. So the first thing I want to do is to shoot it up vertically, and how are you going to help me to tell me how high it is? That comes easier than you think. The top part, we'll remove this. The top part of this stick is 3 meters, the top mark. That very top mark is 3 meters. And all I want you to tell me whether it is yay much above or yay much below. And then we'll estimate that yay much, and then we'll make a guess. And I'll do it twice. So if you're ready, make sure that you can distinguish between above and below. Makes a big difference. Yeah? Okay? 3, 2, 1, 0. Okay, was it higher or lower? How much? This much? Do we agree? Let's say 5 centimeters, right? We're going to allow for an uncertainty. I'll do it again. I want to see how well it reproduces. 3, 2, 1, 0. Lower. Higher. So it was 10 centimeters, 5 centimeters higher, so we'll take 7. So we will make 7 and we'll have to allow for an uncertainty. So H max is about 3.07. I have done this morning 20 times. And there were times that the height differed by more than 10 centimeters, sometimes even 15 centimeters. I therefore would feel most comfortable if you allow me an uncertainty of 15 centimeters in that height. Remember, once we start shooting at 30 degrees, there's no way that we can evaluate the velocity anymore. We have to just take this value